So for objective 13, 14, and 15, you remember we're working on solving systems of linear equations. 13, we talked about graphing. 14, we talked about substitution. And for 15, we are doing addition, also known as elimination. And basically what we're doing, we're adding the equations together. Our goal, we're trying to eliminate a term. That's where the name elimination comes from. But in order to eliminate a term, and when I say term, I mean X or Y. In order to eliminate a term, we add the equations together. And the only way that it will work when we add them together, if we have like negative 3x and positive 3x, when we add that together, that's going to be 0. So that's the goal. We're trying to eliminate one of the variables so we can solve for the other variable. And this example number 1 is like the best case scenario. So we're going to start here. And this is where most of the work is already done for you. And by that, I mean it's already set up for a term to cancel. So if we look at 5x and 2x, if we add those together, we'll get 7x. If we look at negative 3y and positive 3y, if we add that together, we'll get 0y, which is what we want. We're trying to eliminate one of our variables. If we add 14 and negative 7, we get positive 7. So in the end, we have 7x equals 7, so x equals 1. So this is best case scenario, that as soon as you see the system of equation, you can already identify a variable that can be eliminated. After we find what x equals, the same way with substitution, where when we found a variable we had to plug it back in, we have to do that same thing with this addition method. Now that we have x, we're going to plug it into one of our equations. Really doesn't matter which one. That again is up to you. With the substitution method, you want to make sure that whichever one you take to solve for x or y, that you plug that into the other equation. But with the elimination or the addition method, when you add the two equations together and you solve for a variable, then you can take this variable and plug it into either one of the equations. So I'm going to plug it into our first equation, which is 5x minus 3y equals 14. And x is 1. So I'm just going to plug that in for x. And 5 times 1 is just 5. And I'm going to subtract 5 from both sides. So I have 3y equals 9. And 9 will, of course, be, and y will, of course, be negative 3. So because we have a x and a y, then that means that we use the addition method to find the exact point where these two lines intersect. So our answer, we still write it as an ordered pair. It'll be 1, negative 3. All right. Also, for these problems in objective 13, 14, and 15, when the line is the same, it's infinitely many solutions. But in WebAssign, it wants a ordered pair for the answer. So if you guys have been having trouble with that, I'm going to go over that today, how to find the ordered pair when it's the same line, when it's infinitely many solutions. Okay? Example 2. So the way these problems will read, it will say, and this is the only one that I'm going to do this for because I don't want to keep writing this over and over again. But the problem will say, solve by the addition method, and then it will list the systems of equation. Okay. For example 2, we got 3x plus 4y equals 2. 2x plus 5y equals -1. All right. So for example 1, from the jump, we saw that if we added the two equations, we could eliminate the y term. For this particular example, if we add these equations together, the x or the y will not be eliminated. We'll have 5x and we'll have 9y. So when this is the case, we want to multiply the whole equations by a number so that we can make a term eliminate. So if we look at the x's, and remember, in order for it to eliminate, it has to be the same number, but one has to be positive and one has to be negative. That's how we can get it to eliminate. So if we look at 3x and 2x, a way that we can get that to eliminate is if it was 6x and -6x, right? So we have to figure out what we need to multiply by to get this so that we can have 0x, which is what we want. Now, once again, this is completely up to you. You can decide whether you eliminate the x or whether you eliminate the y. But in some cases, one or the other may be easier. So you guys are going to get to see the ones that I would pick. I'm going to take my first equation and I'll rewrite this. And my second equation, I'm going to multiply the whole equation by a number. So I want this to be 6x. So I'm going to multiply it by a 2. I want this to be -6x. So I'm going to multiply it by a -3. So first we're going to eliminate where we've decided to eliminate the x term. After we decide to eliminate the x term, we need to figure out what we need to multiply the equation by so that we can get what we want. Okay? And you can write this several different ways. You can write it like this. However, I tend to just put parentheses around the whole equation and put a number out in the front. Really doesn't matter as long as you're multiplying each and every term in that whole equation by that number. Okay. So when we redo our first equation, it's going to be 6x plus 8y equals 4. When we redo our second equation, and redo, I mean multiplying by that number, we get -6x minus 15y equals 3. All right. So from here, we can see that 6x and negative 6x is going to cancel, and this is what we wanted, okay? So the whole purpose, we multiplied the first equation by 2 and the second equation by negative 3 because we wanted to eliminate this x term, all right? Now that we have that in position, we can add these two equations together. So of course, this is 0x, and you guys don't have to write 0x. I'm just doing it because we're just teaching the principle. As we continue, you probably will see me stop writing it. But I want you guys to see what's happening. So we have 0x, then we got 8y plus negative 15y. We got negative 7y. 4 plus 3 is 7. All right? So what we're left with is negative 7y equals 7. And when we divide by negative 7 on both sides, y equals negative 1. Okay? Now, once we have the y equals negative 1, we can plug it into one of our original equations. So don't plug it into one of the equations that we changed. Plug it into one of the originals. So I'm just going to take the first original. Take the first original and I'm going to plug the y in. So we got 4, then plug in at negative 1. So we got 3x, then 4 times negative 1 is now minus 4 equals 2. And I'm going to add 4 to both sides. So we got 3x equals 6. So x equals 2. Okay, so because we have an x and a y, our exact point of intersection is 2, negative 1. So from now on, since we have it understood that in this objective we're doing the addition method or elimination method, whatever you want to call it, I'm not going to keep writing the solve by addition method, but in the problems, that's what it will see. That's what you will see in the problems. Okay, so if you don't understand this part, then that's the whole point of the addition method. So in our first example, okay, this is what we want. We're trying to eliminate a variable. In our first example, we had negative 3y and positive 3y, which when we add that together is 0y, which is eliminating the y variable. For example 2, if we added the equations together from the jump, we will have 5x plus 9y equals 1, which we still have an x and a y term, which is not what we want. We can't solve with an x and a y in the equation. That's why we want to eliminate one of the variables so we can solve. So you have to decide which variable you want to eliminate, if you want to eliminate the x or the y. I decided to eliminate the x. So when you're thinking about elimination, the same way negative 3y and positive 3y, when we add them together, we get 0. So for elimination, you need positive number, negative number, and that equals 0. So looking at 3x and 2x, I said, let's do 6x and negative 6x and add those together to get 0x. So in order to change in order to change 3x to 6x, I had to multiply this whole first equation by 2. So that's what I'm showing here. I'm multiplying my 2 on the left side and 2 on the right side. You can put the whole equation in parentheses and put the 2 in the front. That's up to you. Y'all will see me do that on the next example. To get from the 2x to negative 6x, I multiplied the second equation, every single term in the second equation, by negative 3. So this is my first equation multiplied by 2, and this is my second equation multiplied by negative 3. So I got exactly what I wanted. This is the goal that I set. I multiplied by these two numbers, and this is what I got, which is exactly what I wanted. Now when I add these two equations together, my x variable is eliminated because 6x minus 6x is 0 x's. All right. Then now I only have a y term in my equation, so I can actually solve for the y. But I can't solve for the y if the x is in the equation, and I can't solve for x if the y is in the equation. That's the whole point of trying to eliminate a variable. So if you think about it logically, it might make more sense. You're trying to eliminate a variable so that you can solve for the other one. So by eliminating the x, we can solve for the y. After we get our y, then we plug that into one of our original equations. I chose the first equation. You can choose the second equation. It doesn't matter, okay? And when you substitute that in, that negative 1 in for y in that first equation, we get now our only variable is x, so we can solve for the x now. Okay, let's look at example 3. So of course we're still doing the addition method, and we're working with our first equation is 2x minus y equals 3. And our second equation is 4x minus 2y equals 6. So the first thing we need to decide is what variable we want to eliminate. Do we want to eliminate the x term, or do we want to eliminate the y term? Okay, so if we want to eliminate the y term, we have negative y and negative 2y. So if I take this negative y, if I multiply it by negative 2, I'll get 2y, which will cancel with this negative y, right? So I'm going to take that first equation and I'm going to multiply the whole first equation by negative 2. So I'll have negative 2 times 2x, which would be negative 4x, negative 2 times negative y, which would be positive 2y, negative 2 times 3, which would be negative 6. Okay? So this is the new equation 1. Now I'm going to add it to equation 2. Equation 2 is 4x minus 2y equals 6. So we're going to add them together. So negative 4x plus 4x is 0. Plus 2y minus 2y is 0. Negative 6 plus 6 is 0. So if this happens, what does this mean? And the key thing is 0 does equal 0, so this is a true statement. So because this is true, that means it's infinitely many solutions. Okay? For everybody that said no solution, is no solution when we get two things that equal and it is not true. Like if it say like 2 equals 6, we know that's not true, so it's no solution. We'll, for where we have that equal sign, we'll put a slash through it because that means it does not equal. And it'll be no solution. Now, an issue that has occurred in WebAssign, I don't think they're taking infinitely many. They want the actual ordered pair. So when the solution is infinitely many, meaning it's the same line, both of these are the same line. As you can see, if we take our first line right here and multiply it by -1, we'll have the second equation. So it's the same exact line. So what you have to do to find the ordered pair for infinitely many solutions result, you want to take one of the equations. So I'm just going to take the first equation. Is 2x minus y equals 3. You want to put it into slope intercept, which is y equals mx plus b. Okay? So we want to take one of our equations. I'm taking the first one, and I'm going to put it into y equals mx plus b. So I'm going to subtract 2x from both sides. So I got negative y equals negative 2x plus 3. Then this is not like this because of the negative y. So I'm going to divide everything by -1, or just change the sign of everything, however it is that you think about that. And I'll get y equals 2x minus 3, okay? So after you take one of the equations and put it into slope-intercept form, which is y equals mx plus b, for your ordered pair, the first term is x, and the second term is 2x minus 3. So basically what you're doing, because this is the same line and it's infinitely many solutions, that means that whatever x you put into here is going to give you a y. And so instead of saying that your answer is xy, it's x, and then you plug this in for y. I hope y'all understand that. So for any x that we put in, we're going to get a y because it's infinitely many solutions. That means that every point on the line is the same. So no matter what x we put in, we're going to get a y that's on the same line because they are the same line. So we put the x, which is our input, and then we plug in what the output is, which y equals 2x minus 3. So we plug that in for y. So the answer is x 2x minus 3. So this is how you get a ordered pair answer for a problem that has infinitely many solutions. And this is what WebAssign wants. When there's no solution on WebAssign, they okay with you typing in no solution. But when it's infinitely many solutions, they want you to give like the overall, ordered pair for the infinitely many solutions. So I hope that makes sense for y'all. So on to example number 4. First equation is 2 over 3x plus 1 over 2y equals 4. Second equation is 1 over 4x minus 3 over 8. Y equals negative 3 over 4. Same thing we did for example 2 and 3, where we multiplied the whole equation by a number. That's what we're going to do over here. So because we have 2 or more fractions in these equations, I would recommend to find the LCM of the denominator and multiply by that first. So for our first equation, our denominator is 3 and 2. So the LCM of 3 and 2 is 6. For our second equation, we got the denominators 4, 8, and 4. So the LCM will be 8, okay? So the same way in previous objectives, we did the where we removed the denominator so that we could make our calculations easier by working with whole numbers. That's what we're doing here. So we're going to take the first equation, and we want to multiply the whole equation by 6. So we got 2 over 3x plus 1 over 2y equals 4. We're multiplying that whole thing by 6. And our second equation, we're going to multiply that whole thing by 8. For our first equation, we should have 4x plus, and I'll write it over here. We should have 4x plus 3y equals 24, and 2x minus 3y equals negative 6. Okay? So now we look, if we do 4x plus 2x, that is 6x. If we do plus 3y and minus 3y, that cancels. So that's perfect. And 24 minus 6 is 18. So we can solve for x. So x equals 3. Now that we have found x, we can plug it into the first or second equation. I'm going to plug it into the first equation because this fraction has a denominator of 3. So I'm going to plug that x in there. So we got 2 over 3 times 3 plus 1/2 y equals 4. So 2 times 3 is 6, divided by 3 is 2. Or if you just know 3 over 3 is 1, and we left with 2. However you do that calculation, as long as you get 2. So we're going to subtract 2 on both sides. So we have 1/2 y equals 2. Now, this 1/2 is being multiplied by the y. So to remove it, we have to divide by 1/2 on both sides. But the way that we divide fractions is we multiply by the reciprocal. So we have to multiply both sides by 2 over 1. So 2 over 2 is 1, 1 over 1 is 1, so we're left with y. And 2 times 2 over 1 is 4. So y equals 4. So because we found an exact x and y, the point of intersection is 3, 4. Let's go on over to example 5. For example 5, equation 1 is 4x minus 8y equals 36. And equation 2 is 3x minus 6y equals 27. So we have to decide which variable we want to cancel or eliminate. So if we look at our x's, we have 4x and 3x. If we look at our y's, we have negative 8y and negative 6y. So I think we should cancel out the x's. So let's just look at the x's for a minute. And we want to get something that's the same and opposites of each other, so that when we add them, we'll get 0. That's what we want. So if we look at 4 and the 3, if we multiply this one by 3 and this one by 4, we'll get 12x, but one would have to be the opposite. So let's say we do this one by 3 and this one by negative 4. We'll get 12x and negative 12x, which will be 0, which is what we want. Okay? So with that being said, then that's what we're going to do. We're going to take our first equation and multiply everything by 3. And we're going to take our second equation and multiply everything by negative 4. So our new first equation and our new second equation is going to be 3 times 4x, which is 12x, 3 times negative 8y, which is negative 24y, and 3 times 36, which is 108. So now for our new second equation, we have to multiply each term by negative 4. So negative 4 times 3x is negative 12x, which is what we wanted. Negative 4 times negative 6y is positive 24y. And negative 4 times 27 is negative 108. Okay. So in trying to eliminate the x term, we done messed around and then eliminated the x term and the y term. So this side is 0. And 108 and minus 108 is 0. So because 0 equals 0 is a true statement, we know that it is infinitely many solutions. So because Weber-Stein wants the ordered pair, let's find the ordered pair for this. So what was the first step that I told you guys to find the ordered pair when it's infinitely many solutions? So we got to take one of the equations and put it in slope-intercept form. So I'm going to use, which one? Let's take this equation, 4x minus 8y equals 36, and put this into slope-intercept form. So we're going to subtract 4x on both sides, and we have negative 8y equals negative 4x plus 36. We have to divide everything by negative 8. So y equals 1/2 x minus 9 over 2. So Infinitely many. That means that for any x we plug into the equation, we're going to get a y that's on the same line. So for x, which is the first term of our answer, and we plug this in for y, so it's x comma 1 over 2x minus 9 over 2. This is the answer. For example number 6, equation 1 is 2x plus y equals 5. Equation 2 is 4x plus 2y equals 6. Hope y'all can see that. So I want to eliminate the y. I want to eliminate the y term. So because this is 2y and this is just y, I'm going to multiply the first equation by negative 2. So if I multiply this first equation by negative 2, I'll get negative 4x minus 2y equals negative 10. Okay? So I changed the first equation. Now I'm going to add the second equation to it. All right? So my plan was to eliminate the y, right? But negative 4x and 4x, that's 0. And negative 2y plus 2y is 0. So on this side, I have 0. So I actually eliminated both terms by multiplying the first equation by negative 2. Okay? On the left side, I have negative 10 plus 6, which is negative 4. All right? So we have 0 equals negative 4, which we all know this is not a true statement. So we put that slash in there because 0 does not equal negative 4. That's what this says. And when we are solving systems of equations, when we get two things that do not equal, what is our answer? That's right. No solution. All right. So today we looked at the 3 cases, the infinitely many, the no solution, and the exact point for using the addition method. If you have any questions, please rewatch the video. I hope you guys understand this material. If not, let me know so we can look at some of these and other problems during the Zoom class. So y'all have an awesome day.